This call is now being recorded.
Am I audible? Somebody can reply.
Yes, sir, audible.
Thank you. So today I think we are going to start unit number 6, that is turbines, hydraulic turbines. It is a impulse water turbines. So I think in BME you will learn much more things about turbines, the basics of turbines you will learn. So is it correct? Now where in last semester we have discussed about steam turbines. Now we are going to discuss about the hydraulic turbines. Now turbine means what? Anybody? So this is a very 40-minute lecture. So now I think 4:30 when there is IAC papers are there. Only I think 20-25 minutes we are going to discuss. So today we complete the classification of turbine and some basics of turbine. So hydraulic turbines means what? Anybody? Anybody can define hydraulic turbines? What is by turbine first? You define in thermodynamics, BME. Somebody can unmute and tell what is by turbine. Nobody. Turbine is what? Anybody? Water turbine is a rotary machine or any turbine. Okay. Here, Swas Kunal Seti. Turbine is a rotary machine that converts kinetic energy and potential energy of water into mechanical work and rotate the shaft to produce electric energy. So whatever the hydraulic energy is there, that is with water, that is converted into kinetic energy and potential energy of water. That is and kinetic energy first, and afterward that kinetic energy is utilized to it is again that high velocity water jet is impacted on the blades of turbine and turbine rotated. And these blades are connected to the shaft. Therefore, turbine shaft will rotate. And if this shaft is rotated in presence of electromagnetic force, in presence of magnetic field, then electromotive forces EMF is generated. That we call it as electricity. So like steam turbines, water turbines, purpose is also going to be same. Only thing is there in steam turbine we are using thermal energy as the input. In water turbine or hydraulic turbines we are using here hydraulic energy as a input. So hydraulic turbine converts potential energy of water into mechanical energy. So the chapter contains the definition of hydraulic turbine, classification, types, and difference between Pelton turbine, Kaplan turbine, and transistor. Now, these are the turbines I think everybody is aware. Okay. Hydraulic turbines converts the potential energy of water into mechanical. Potential energy or kinetic energy. Or in general we say hydraulic energy of water into mechanical. Then turbines are classified as here based on the head. How much head, that is potential height of the water is there here above the turbine axis. That is called as head. Then depending on that particular head, turbine surface. Just a minute, you read this slide. I will come in 1 minute. This is certified that Solapur University does not have any formula for certificate. We never required a conversion of certificate, not chemical marks scored by the chemical. जिकून दिले आपण त्यांचं फॉर्म्युला त्यांना जातं डायरेक्ट जातं तुम्हाला पण लावतो विद्यार्थी लोक नाही फक्त त्यांच्या त्याला पाहिजे काय म्हणलं तर तू म्हणायचं म्हणजे आता कोण देणार आपण देणार प्रिन्सिपल लिहायला आपण डॉक्टर लिहिलं टू होम युअर एकमेकांचं त्याला पाहिल्याला
Sorry, I think I was not audible. I think I was okay. So based on height turbine, medium turbine. So head means what? It is the height of the water above the turbine axis or turbine blades. So this is high head turbines are there, medium head turbines are there, and low head turbines are there. High head means what? If the head of the water, the head of water, height of head of water is more than their 100 meters. That are called as high head turbines. And the example are high head turbine. Anybody can tell, unmute and tell. Anybody of you? Anybody of you can define which is high head turbine? Pelton turbine is there. It is going to be one of the high head turbine. Pelton turbine. Pelton is the example of what? High head turbine. Pelton wheel we can call, or we can call it as a Pelton turbine. Then medium head turbine, if the head is in between 50 to 100, then it is called as medium head turbine. An example is what? Francis turbine. Here example is what? Francis. So these are the names of scientists. So after their invention, after their as name is given, they have invented, therefore name is given as Francis turbine. And then low head turbine, example is what? If the head is less than 40 meter, etc., then it is called as what? Kaplan turbine. Low head turbine. An example of the low head turbine is Kaplan turbine. Okay, understood? Then based on the hydraulic action of water, it is impulse turbine, and then are called as reaction turbine. The impulse turbine means what? Whatever all the hydraulic energy is there of the water, if it is converted into mechanical energy, okay, then it is called as what? Kinetic energy. Then it is called as what? Impulse turbine. And then reaction turbine, during the stages, so the hydraulic energy is not converted into kinetic energy at once, but only during the stages it is converted into kinetic energy. So all pressure, potential energy or pressure energy not converted here in one stroke. So during stages where that is conversion happening, it is called as reaction turbine. Then, based on the direction of flow of water in the runner, the tangential flow turbines are there. Tangential flow means what? Whatever the water is flowing along the axis of the turbine. Radially, if the water is flowing radially, it is called as radial flow. Then axial flow along the axis of the turbine, and mixed flow. It may be the combination of tangential, radial, tangential, axial, radial, axial. So if the two flows are mixed, then it is called as mixed flow turbines. Three most important turbines are, everybody know, one is Pelton wheel, another is Kaplan turbine, and third one is Francis turbine. Now first is what? Pelton turbine. So everybody understood classification. More classifications are there. We'll take next lecture because today I think less students are there. So next lecture will come with our original notes. Till that, I wanted to give introduction. So these practicals are also there. So here, Pelton wheel is one of the turbine. Everybody understood up to this? I think you all learned this. This is basic. Please reply. Yes, yes, at least. Today I think what as end of the yes, yes, okay. Rahul, Kunal, okay, Shaneshwar Misal, Kunal, okay. Shivani Nani, yes. Nikita, Dikshad Mile, good. Okay. Then Pelton wheel is an impulse type of turbine, impulse type of water turbine. So hydraulic turbines, or we can call it as a here water turbine. Akshay, good. So Pelton wheel is an impulse type turbine. It is invented by Lester Allen Pelton in the 1870s. So as the name is Lester, the name is invented by Lester Allen Pelton. Hence, hence the name is known as Pelton wheel or Pelton turbine. So this turbine is used for high heads. Means what? If the head of water is much more, then it is called as then it is suitable. So components of the Pelton turbines are runner, nozzle and spear, then runner and bucket, casing and braking jet. So these are the four important components of the Pelton wheel turbine. So first is nozzle and spear, then runner and bucket, casing and braking jet. Nozzle, it controls the amount of water striking the vanes, and speed it will consider it control. Casing, it is used to prevent splashing of water. Okay, it is atmospheric pressure is there at inlet as well as outlet, though splashing of water it prevents. Then runner and bucket, it is circular disc on the periphery on which evenly spaced buckets are fixed. And braking jet is the it is a function is to stop the runner in short time of period. Okay, so we'll go in detail now. So this is the casing of the Pelton turbine. So whatever there here is the casing. Okay, the casing purpose is there that it is preventing the splashing. Okay, then here spear and nozzle assembly is there. So it is hand wheel is there. Okay, so through which this spear wall can be here spear can be put can be reciprocated into this particular nozzle. Okay, into this area. So and it will control this spear is there. It control the speed of water on this particular bucket. And here at the end it is nozzle is there. So nozzle means what? It converts potential energy into kinetic energy. So at the end of nozzle, here at the end of nozzle, the pressure kinetic jet of water will be flowing on the blades on the buckets of the turbine. So these are called as cup buckets. It is cup buckets are there. So these cup buckets are there. These are mounted. So these buckets are there cup type of buckets. Okay, they're mounted evenly on the periphery of this particular runner. So this is called as runner. Why it is called runner? Because when due to the splashing of jet on this particular buckets will rotate, and these buckets are rotated mounted on this particular shaft or runner. It is rotating, therefore it is called as runner. And then it is shaft is also going to be rotating. Okay. And therefore, as this is going to be rotating, runner is going to be rotating. So this is runner and bucket is one of the very important important component of a Pelton wheel. So it is circular disc on the periphery on which evenly spaced buckets are fixed. This is called as runner. So this is runner and bucket. This is casing. This is your nozzle and spear assembly. Then another is there. It is called as braking jet. So opposite direction also we can up here flow. Suppose that this is the flowing in this direction. So sometimes we are when we want to stop this particular bucket. So again in opposite direction of that particular spear nozzle assembly, opposite direction of water jet were impacted on the buckets so that it will stop. So every action equal amount of force is going to be offered or acted or make to make act on this particular buckets so that it will stop this particular runner in short time, and it is called as braking jet, like a nozzle only but in opposite direction. These are the components of this particular Pelton wheel turbine working. The flow of water is tangential to the runner. So the direction of flow of water is what? Tangential to the runner. Okay. So it is in tangential flow impulse turbine. So flowing in direction type, it is called as what? Tangential flow impulse turbine. Okay. So runner consisting of a single wheel mounted on a horizontal shaft. Water falls toward the turbine through the pipe called as penstock and flows through the nozzle. The high speed jet after nozzle, we are getting high speed jet of water hits the bucket vanes, or it is called as vanes also, on the wheel and causes wheel to rotate. A spear rod, which is a spear assembly. So it is spear rod assembly there. It is it controls. So this it control spear rod which has a spear shaped end can be moved by hand wheel, and this movement control the flow of water leaving the nozzle before it strikes the bucket. The bucket of vane is so shaped that when the water strikes, it gets split into and two, two and gives it an impulse force in the center of the bucket. This bucket is called as splitter. This bucket is known as splitter. So like this cup-shaped buckets are there. At this center of the bucket cup, so there is a one line here. There is a splitter is there. So this splits the water jet into two halves. One half in going and this is called as splitter. हे जेटा आहे एक लाईन आहे इथून बघितलं आय थिंक. Okay, so this is I think pictorial view is there of nozzle spear same thing bucket. So this is bucket is half bucket is double cup type is a double hemispherical, we can double hemispherical, and one splitter splits that jet into two parts. So that split that or splitter is the splits the jet into two halves, two parts. So, and then rotation will happen. So this is rotation is only kinetic energy where apply. So this is a very simple type of impulse turbine. It's called as Pelton wheel. So I think you might have observed that Pelton turbine in our laboratory also. So this is a station power generation. Very high, as high head is there, we can generate more power from this blade because high heads are more. So Ambala cantonment in India station. So this is one of the Pelton turbines famous. So where 800 megawatt power station Pelton wheels are used. Then Switzerland, Swiss. So here Bayern, one of the station is there in world Swiss. So it is generating one near more than 1250 or 1200 exactly 1269 megawatt. And in United States, it is Castec is there, where the big Pelton turbine is there, with generating 1500 megawatt. So understood Pelton turbine? Very simple. Everybody, please write message in chat box.
Yes, sir.
Okay, thank you, Swaz. The others, please reply. Okay. Okay. So another type of turbine is there. It is going to be a Kaplan turbine. So again, it is all the names are there. Pelton, Kaplan. These are names of scientists. I told many times. So one of the turbine is there. It is going to be Kaplan turbine. So Kaplan turbine is a propeller type of water turbine, which has adjustable blades. So these blades are there. Kaplan turbine is there. This is going to be propeller shaft is there, and adjustable blades are there. So these blades angle, these blades we can, these blades are going to be adjustable. So these blades we can make horizontal completely. inclined. So okay, and it was developed in 1913. So I think almost 110 years near about back. Okay, by uh, Austrian professor Victor Kaplan. Victor Kaplan. So hence it is the name is given as Kaplan turbine. It is mainly used for low head application. So where if there is a low head is there, if there is no high head is there means uh, height of that particular mountain etc. is very less, where from the which we are getting water. So here that type we can use low head turbine, Kaplan turbine. So in our nearby centers, if we want to visit, so Radhanagri Dam is there, our Radhanagri Dam. So it is there, Pelton turbine is used. So specifications is there, it is going to be 10 to 70 meters. So some books they have given different specification that range of low head. So generally 70, 10 to 70 meters. The output varies from 5 to 200 megawatt. Okay, so 5 to 200 megawatt. Then runner diameters are in between 2 and 11 meters. Okay, water diameter. This is called as runner. Yellow is there. It is called what? This is called as runner. Okay, so this will be runner. And so the diameter of that particular runner is in between 2 and 11 meters, up to 2 to 11 meters. Rotational speed. This will be runner. And for this runner propeller shaft, so the adjustable blades are there. So the rotational speed range in between 70 rpm, we can 70 to 430 rpm. It gives the highest efficiency 90%. Okay, then it consisting of that particular propeller shape. So working. Draft tube is there, it is essential because it is pressure is decreasing at the outlet. Pressure is decreasing too much, less than atmospheric pressure. So the water cannot be what we discharged to the outlet. Therefore, draft tube is required. Runner, it is connected to the shaft of the generator, and hub, it is a part on which runner is mounted. Okay, so this is the inlet of the Pelton turbine, here Kaplan turbine. The water is coming through this particular inlet and it is here. This is impacted on the adjustable blades. So due to that, here these blades will rotate, and these blades are directly connected to the propeller. This propeller will rotate, and this propeller is what? Propeller is rotating. It is nothing but it is connected to the runner hub, and this hub will rotate. Only rotations we want to generate. So this is a adjustable blades. We are here. Spiral casing is there, and through which here the water is through nozzle is impacted on the adjustable blades. Adjustable blade rotate, and it will rotate with that particular hub or runner connected to that particular hub. Okay, and here guide. Now there are two types of blades are there. One is guide blades are there. Their purpose is what? To guide the water, so that water will impact here on the properly on that particular blades, okay, or that buckets, okay, blades on that particular turbine. So here, so for that guide blades are there, and it is these are fixed one guide blades are there. So and these will not move, but these will direct that particular water on that particular blades of that particular turbine. Then we are having this particular kind of spirals casing. So again, the casing is also designed so that and when water is going to be coming into the inlet side, its velocity goes on here increasing. So like this, the shape is going to be flow of water here. Flow is going to be decreasing. Area of that particular flow is going to be decreasing towards the entry inlet. Okay. Then we'll go in detail now. Water flow here. Sorry, here water is going to be flowing. So area at inlet is more, and when it is coming inside this particular through the spiral casing, the area is goes on decreasing. So that area is goes on decreasing is what? The velocity is goes on increasing, because in the dynamics we know that direct area is directly proportional to the velocity. If area is coming more less, area is inversely proportional to velocity. As area is become lesser, velocity will become maximum. Like जेटचा एरिया कसा असतो, नोझलचा कमी एरिया असतो त्याचा, पण व्हेलॉसिटी वी कॅन गेट मोर. Similarly, this casing is at outlet inlet side having more area. Okay, and when it is coming into this direction, so area will become lesser and lesser, so that velocity will become more. And turbine, if kinetic energy as an input is more, definitely output can be more. So this way, here it is going to be impacted on the blades, and guide blades only direct that particular jet, so that it will be effectively properly impacted on the blades, and that blades are connected to the propeller shaft will rotate. Okay, and therefore we are getting the power, means rotation, and if that rotation will be carry in the presence of magnetic field, EMF can be generated. So our purpose as a mechanical engineering is generally up to rotations of that particular shaft. Then afterwards, maximum, generally we say that, and afterwards, if rotations in to produce the EMF is the their duty of electrical engineer. When we will work in that particular power rotation, etc., you have to your up to generation, power generation, only our role is limited. Electrical engineer will take care of the EMF, etc. But we should know knowledge. We should know what I'm. Then water from the penstock enters. Penstock means a big pipe is there through which water is here from the dam is going to be taken. So water from the penstock enter the scroll casing and then moves into the guide vanes. From the guide vanes only direct. Okay, so here it is clearly water is flowing inside. It is flowing into that runner. Okay, so from the guide vanes, water turns through 90-degree and flows axially through the runner. Okay, for Kaplan turbine, the shaft of the turbine is a vertical shaft. Okay, so, so these are, when we are drawing the velocity triangle, these information is very essential. So after guide blades, the water turns through 90-degree and it is flowing along the axis. So it is hence it is called as Kaplan turbine is called as axial flow turbine also, because water is flowing along the axis. For the Kaplan turbine, the shaft of the turbine is vertical. The lower end of the shaft is made larger and is called as hub or boss. Okay. So like this Kaplan turbine, like this construction is there of this particular shaft, or like this. Okay. The lower end of that shaft is made of larger. Okay, the lower end of the shaft is made larger and is called as here hub or boss. The vanes are fixed on the hub and hence hub acts as a runner. So this is the animation is there. This is the blades, propeller shaft, spiral casing. So water is impacted on that particular adjustable blades. This is the propeller shaft. Okay, and this shaft is made of what? Here it is like hub. So hub means what? Generally on these particular blades are mounted, and this is made larger at the bottom side, at the lower end. It's called a hub. Okay, the vanes are fixed on the hub and hence hub acts as a runner. म्हणजे ह्या हबलाच, this is called as hub. बोट लोअर एंडला तो काय असतो, हब असतो. हा एंटायर शाफ्ट, दिस इज कॉल्ड एज शाफ्ट. त्याचा लोअर एंड कसा आहे, त्याचा हब म्हणतील, कारण त्याला ब्लेड्स आर अटॅच्ड ऑन दिस पर्टिक्युलर हब. So this is going to be hub and lower, it is at the lower end. The vanes are fixed on the, so this is one of the Kaplan turbine animation. So draft tube is required because after that particular hub, so water pressure will become too much less. Too much less means it will become less than atmospheric pressure, and we know that water flows from higher pressure to lower pressure. So it was not because outside here pressure is atmospheric pressure, and inside after hub here pressure will too much decreases too much, and it will become less than atmospheric pressure. So therefore water cannot flow from that particular from the turbine to the reservoir, because reservoir, and so hence one draft tube we are using. So draft tube purpose is what? To increase the pressure of that particular water coming from immediately coming from that turbine, so that it will become more than atmospheric pressure. And for that we are using the draft tube, and draft tubes are there. Say again, same another same basic we are using that area of that particular tube we are increasing, As area is goes on increasing, what will happen? Pressure is increasing and velocity is goes on decreasing. We are not bothered about velocity after the year when it is coming to from the draft tube. So only we are interested to that pressure will become what? More than atmospheric pressure, because after giving converting all potential energy or pressure energy into kinetic energy, water's pressure becomes too much less, and it cannot be coming out from that particular turbine. Hence draft tube will increase the pressure and decrease the velocity, and water can flow to the reservoir. Hence this is called as draft tube. Then Kaplan turbine used in air stations are there, simple Indian. So LPH is there. Here Kadra Dam is there. Kodasalli Dam is there. Almaty Dam is there. So where power generation is 55, 150, like this table. You can LPH here there. I don't 55. Kadra Dam in Karnataka, it is 150 megawatt. Kodasalli Dam is there 120. Almaty 275. And if here in Kolhapur, Radhanagiri Dam, I have visited. There also one Kaplan turbine is there. So I think today we'll stop with this Kaplan turbine and this Francis. So next class we'll go for Francis turbine and then afterwards details. So because at 4:30 our some of the students IAC is going on. Some students have submitted IAC, but I have not here. Because maybe few students are there, 4 5 students. I have told they have to send this paper on WhatsApp, and then I will consider their paper attendance. If you understand this Kaplan turbine, working of Pelton turbine and Kaplan turbine, then write yes, and so that we'll close the lecture today. Yes, Shivanani, yes. Okay, good. Thank you. So we'll stop today.